Hello, everyone. Happy to see you here again. We will start our second masterclass now. And our second masterclass is on photogrammetry. And our teacher and lecturer today is a person who has education in art and also in technologies. So this wonderful spot where you can experiment with technologies in a creative way and finding new ways how we can move forward. And today we will talk for 2 hours. If you have any questions, you can type them in chat or on YouTube, or just raise your hand and ask your questions. So we can start now, if you're ready.
Hi.
Excellent.
All right. Yeah. Hello. I'm Alvis Misjuns, and let me just screen. Yeah. Welcome to the Hybrid Lab second event, and it's going to be about photogrammetry. Well, not only photogrammetry. We'll also talk about how can we share our creation a little bit a wider public. And yeah, as mentioned, I finished Art Academy, and I also went in with the University of Applied Sciences in the Virtual Reality and Smart Devices department, and it was a really nice experience, a really great one. And yeah, it let me opened up new possibilities in my creative work. So yeah, so this recording will be, and I understand it will be available to you, and it's going to be 2 hours. So I think I'll help you a little bit in how to orientate in those 2 hours. So the first half an hour, 30 minutes, I'm going to do a little intro into photogrammetry, how 3D reconstruction works. Then in the second 30 minutes, I'm going to hands-on with software, how do they work, what to expect. Next, the fun part, retopology and texture baking. Using Blender, it's a 3D software. So, and in the end, a quick intro to webGL. Well, it's mostly through A-frame. I'll show you some A-frame basics. And all right. So yeah, here's a question: why photogrammetry? I think in the first event, the photogrammetry was mentioned, and yeah, well, because it's cheap. Not everyone can get an expensive laser scanner at his disposal. So photogrammetry is available for everyone. Mobile phones are really nice. 2 or 3 years, mobile phone cameras are really good if you have enough light and you know some little nuances how to achieve good results. And yeah, you can really with the simple phone achieve really a 3D picture and do what. And if you know 3D modeling, you can do whatever you want with it. And and I've kind of, I don't know, the drive for I kind of see it like some kind of technology and art, and or come together, and this kind of magic happens where you can have when you really can make a virtual object from a real one. And so and well, I'm working in the XR field. XR is an umbrella term for extended reality, which encompasses virtual reality, augmented reality, and mixed reality. Well, augmented reality and mixed reality gets somehow all the time mixed together, and which is which, right? But there are some differences, and yeah, you can check my work at my homepage. I had some virtual reality works exhibited, and using game engines like Unity and Unreal, really great engines. Really, I like them both. They're really, that really depends on the project that you need to accomplish. And yes, so and yeah, the last year I was working more on. I did my master's in Vidzeme University Applied Science, as I mentioned previously, and my master degree was on what was the name, like fast and fast portrait 3D scanning, something like that. And I've got a hand on like 28 Canon cameras. I think it was T5s. It was a really great collaboration with Overly, the augmented reality company. And they had those cameras. I just needed to set up to understand the distances and the best setup for 28 cameras and to make a fast portrait. And what I understood in my making my master degree, that photogrammetry can in some cases achieve even better detail than some laser scanners, but again, some laser scanners, and it really depends on how do you light the model. And photogrammetry has a superior power which no like other laser scanners or other type of scanners has. That is the texture quality. The texture quality, like you can put an expensive camera, like high resolution 40 or 50 or 100 Hasselblad megapixels, Hassel pixels, and you can like really achieve like crispy texture. You can have a model of like a potato underneath, but if you have like a really good texture that hides a lot of defective texture model underneath. And yeah, another thing about photogrammetry, if you have like in your arsenal like 28 or 100 or more cameras, you can wire them up and you can make world's fastest 3D scanner, because if you have enough light, it's like 1/10 second, you just scan and that's it. You have like 100 pictures of the same from all sides, and then the time takes there's some time for reconstruction, but no other scanner can like capture you while you are jumping or while you're like pouring something or falling or something, or on an or like it's really good for capturing sports movements. And after that, I got this ambitious project to reconstruct some parts of the art academy to make this virtual exhibition. It's you can take a look at it. It's virtual.lma.lv, and you can roam around the academy a bit, and there are the last year's diploma works around. So I had a fantastic team working on it, and really great experience. And of course all these years also I'm like watching over the motion capture studio in Janis Rosenthal's art school. We had this for some quite time, and it's kind of frustrating working with it sometimes, but the results are you cannot get any like you cannot get like it's like the precisest thing you can get in like capturing 3D motion of a person or of a dog or of some kind of event. And I do like the same. I work a little bit like with motion data, retopology, not retopology, but and they say like fixing motion, fixing retargeting, like putting 3D characters in motion. You can check my Instagram also, I have some examples. So and the real big thing that I'm really excited and waiting for, and why I'm like diving deeper into the photogrammetry and the webGL part is because really of the mixed reality. And the mixed reality compared to the augmented reality is like the line is really getting blurred, but mixed reality, it's more about that the device understands the room, it knows the room, it knows where the ceilings are in, And one major thing is that it remembers it. You can return it to the next day to that same room, and it remembers where you placed your 3D object. And that's like mixed reality. Yeah, and that's like the mixed reality. And I got to play around with HoloLens, the first model of glasses from Microsoft, and I felt that, yeah, that's that's gonna come and that's gonna stay. And someday, maybe after 5 years, maybe more. But yeah, and well, when those, you know, that like virtual reality glasses, they have this kind of like niche. It's right now only like real diehards and enthusiasts use them, and but still the community is growing. But it's still, the problem is that it isolates you. But mixed reality, you can still like be in the real world and in the virtual in the same time. And well, yeah, I and some have the feeling that it's gonna stay, and for that you will need a lot of content, and you will need to know how to make that content. So I think these are like photogrammetry and webGL are the really right way to make accessible content, so you can view it from any device. And yeah, that's what we're gonna do today. I'm gonna just show you how you can capture, virtualize a real object, and make it available to the wider public. So yeah, it's mostly making content for the XR world. So yeah, about photogrammetry. So I won't delve into the past. It's like from the 19th century, the methods and techniques were around, and they like spun around for quite some time. But the real renaissance for photogrammetry is like I don't know, like 20 years ago, 10 years ago, well, when the computer had enough power to compute all those feature points and distinguish what's where. So yeah, and the principle of photogrammetry is really simple and complex at the same time. Well, it's as you maybe notice that laser scanning, it emits rays, and then it detects how long the ray is, and then it detects the surface, right? Well, approximately like that. But photogrammetry, it's like from a photo and from a lot of photos, and it tries to find the similar spots on each photo and try to understand what's the difference between the points, and trying to understand those differences, it can reconstruct the model in 3D. And that's why like the feature points are really, well, that's the thing that you need to understand when working in photogrammetry, because well, I'll show you some examples later. So yeah, it's more like, yeah, as I said, like creating virtual copies of real objects. That's a fantastic way. Yeah, like preserving heritage and creating something and showcasing it to someone else. It's a really nice and fast method of sharing. So yeah, as I mentioned, yeah, the lasers versus laser scanning, it's well, mainly it's the texture image quality. It's just right now uncomparable. Maybe it's gonna be really similar. Oh, and of course the best part is that there's some studies that, not studies, but some method where you can combine like laser scanning and photogrammetry, and then you get the best results. You have the precise model, and you have real high resolution texture. But that's really complex. It's also, well, I don't have a laser scanner at my disposal, so I can't really test that out right now. So yeah, and photogrammetry was always favored for photogrammetry was favored in like archaeology. We have a drone, or you just take some photos around, and then you can like reconstruct the heritage and see it from a different point of view. Yeah, Google Earth, of course. Yeah, they also use photogrammetry, and they use different technologies, but one of them also was photogrammetry, where a plane was like flying through, and like a lawnmower, and like a lawnmower, and like scanning cities. And you can see some really interesting. Right now, this picture is really like seems perfect, but there are really nice defects. Maybe in the previous, in the first first meeting, where you saw some images where the artist collected like those awkward images where like the bridges were like just laid down on the flat, and yeah, something like that. Yeah, and of course, yeah, one of the biggest usages for photogrammetry is game world creation. And even right now, maybe you heard of it, like virtual studios, virtual production studios. You can check out the Mandalorian, how it's made, and it's practically, you have this big LED, big HDR screen studio all around, and it lights the scene, and it's attached to a camera, so the perspective is always right, and the 3D artists are like nearby sitting and changing something in real time, and it's really fast, and it's really dynamic, and more you can see the results already than just guessing what's going to be. And it's a really nice technology. And yeah, and of course, for realistic model acquirement, you need photogrammetry. Well, and yeah, for those who do photography every day, congrats. Yeah, it's much easier. As I saw that the most difficult part in photogrammetry is just understanding the camera settings, and how can we achieve a really sharp image. And here we must understand the 3 settings. Oh, 3 really? I think there was 4, but all right. And yeah, one funny thing is that yeah, we the light, we don't see the light as we need to see it. For example, yeah, it really depends on the camera you have, and the more expensive cameras have those sensors bigger, so less light is needed to expose nicely your shot. So, and the phones have very little really small sensors. That means that less light get in. That means that you need to throw as much light as you can on your object, so it would be like crispy, and there would be no noise reduction. And noise reduction is really bad because, well, it draws on top, and every image is then like a painting, like drawn differently, and those feature points are getting lost. The same is for noisy pictures. So the one thing you need to understand here is you need to know your lens, you need to know your camera, and the best here is that the f8 or the f11, the focal length, because as you see here on the preview, you really need to get rid of blurry backgrounds, because, well, when you like photograph an object, well, the front is sharp, but the back is getting more blurry. No, you need to get that also sharp. So you need to close up that diaphragm and f-stop. So, and while closing it down, that means you have less light coming in. Even that means you need more light. And again, the shutter speed. The next thing is, so yeah, another a really good illustration that 1 in 1,000, it's like for sports, but again, imagine like it closes up 1 in 1,000. Also, again, the faster it closes, the less light gets in. And again, you need to understand what to give up. For example, yeah, if you have a really steady hand, you can do the 1 in a 60 second, 1 in a 60 second, something in the middle. But really, better take a tripod. It depends also on the camera. Some have those stabilization things on them. And Yeah, yeah, and 1 second from the hand, it's not fine if you need to take 70 or 100 photographs. Well, you have you need to have like abnormal patience for that. And of course, the next setting is ISO, which is the film sensitivity, an old term, but works still similarly. The ISO must be as low as possible in any case. Also depends on the how large is your sensor. So let's, yeah, I think that's it. Yeah, you need to focus on light, sharpness, and resolution. Yeah, there are some really cool software applications on mobile phones. Maybe you saw some. One was recently called Displayland. It allowed you to use your camera and it, like on the fly, just filmed, and it worked like this, like a scanner. And well, the results were a little trashy but fun. And for some cases, it's just enough. For reference, also really good. And and right now, if you have the newest model phones, they have this R-Core and R-Kit usage, that a new augmented reality like engine or library in phones that understands where are floor, roof, ceilings, everything, and it understands the space better, and it also like works like photogrammetry and in your phones. And of course, the biggest take is the biggest um, achievement probably is like the iPhone 12. It has that LiDAR scanner at the back of it, like on the cameras. It was meant for focus. It was meant for yeah, like for better focusing in the dark. But of course, the developers used it in for yeah, like if you have the rays, you can use them as scanners, and it, like you can really have also like achieve even better, really good results also with mediocre texture. But yeah, you can get some really good reference shapes to model on afterwards. All right, so and yeah, the thing, as I mentioned before, the feature points. Well, here's just like illustrative image how the computer sees your image. Well, it tries to distinguish unique pixels, unique, not pixels, a group of pixels. And you can check out that site underneath. It explains really technically good how it works. It really helps to understand what and how to photograph to achieve the best results. And it like the software which reconstructs it detects features, and it tries to then compare these features between photographs, and some have like with a little distortion similar, and then it attaches and understands that that's the same and those the same, and then tries to understand what's the difference between those locations, between the feature points, and using that information you can understand what's the 3D. It's like, yeah, Pythagore theorem, like in math that you've done. Just it draws triangles a lot. And yeah, for scanning, like a really rough example, like a bad choice would be like this rubber shoe without any detail. It's also a bit shiny. Like with eye, could you distinguish, like you could distinguish only some features also, maybe this flag or what's the decoration and this logo and maybe something somewhere else, but that's not enough. You're gonna have a potato in the end. So, and a good choice is probably this hunter's boot. That's really like tried being disguised, but it has a lot of unique features. It's still a little bit shiny, but it's better than the simple rubber boot. And yeah, so again, bad choice is just photographing white sculptures. Well, there's here in school also we tried to capture some to like preserve, but no, it's not. You need to, if you really want to capture that white sculpture, then one thing you can do is spray it with some kind of charcoal or paint, make it feature rich. You can draw some X's, you can stick some things on top of it, but the best thing is what you can do is spray it with something and it's gonna be fine. Like the sculpture on the right is a good choice. In this case, it has a lot of unique details. Be aware of contrast too. Like the shady part, it's gonna, if your camera hasn't like HDR or has a small, well, if the technology isn't there, then you won't have anything in the dark shadow there. So need to be aware of that. But okay, like the tab, it's a very bad but the interesting choice. You can try it out. Maybe it's gonna catch on something, maybe not. Depends on how dirty or clean it is. Because imagine like every image, it's you just take a look at it. You cannot. It's like it's like camouflage or something like that. You cannot distinguish its form easily because everything changes in every new frame, in every new position. So and the method usually it's really simple. You just go around your object and in 3 or 4 layers as needed, as the difficulty of the object. Like if it's more like complex, then do more. And it's better to make more images than less, because you can always delete later. And in first tries, it's always like half pictures are really blurry because of the shaking hand. So we really need to train that and try to then take a lot of pictures. Some also tried to make the burst mode and just walk around. No, you have constantly blurry images. All images will be blurry, especially if you're doing that in the dark. So, and the best for best results, at least 70 images are needed. And fill the frame. You don't need like empty spots. It's no use. You imagine that you can count the pixels on the image. You can count the megapixels and understand how is useful and how is not. In the end, maybe have a 50 megapixel camera, but your object is just like a 12 or 10 megapixel, something like that. That's so better crop some things out, but frame it all in, fill the frame. And I suggest going around the object. You also can put on the really like black background or only white background, but it's really difficult to achieve. You need the studio oftenly, and the first time when you're trying it, it's never successful because the background always have this gradient, and that gradient catches on the reconstruction program, and it confuses. It's like saying it's strange that how is that the same features are all the time in the same place on the background, but the object feature points are changing, so it cannot draw conclusions. Every point counts. So how does it work? 1 minute for this. Well, it's all the reconstruction programs use the same algorithms. The first one is called structure for motion. It roughly detects some features, approximates where the cameras are located, like reconstructs the camera positions against the object. And then it uses the multi-view stereo algorithm. You can also check the papers. I put the links under the images. And what multi-view stereo does, it takes a pair of pictures and intensively compares the feature points, like it showers it with rays and then searches really hard, and then you can achieve a really good high detail model if everything's fine. And those 2 main steps. And okay, here's some software that I recommend taking a look at. Well, reality capture is really the best that there is. right now. It does the fastest, and it does the quality. I've done it like doing my master's. I compared the reality capture, Mushroom, and Agisoft, and of course, reality capture has some kind of this magic algorithm that it understands and finds a human face or some objects that it understands, and it makes it like perfect. While in Mushroom and Agisoft, it was more like generated potato, not a face. And well, I don't know how it's now. It was like 2 years ago when I checked. And no, 2 years, it's like a century in computer software. So I saw that there's a new version for Mushroom, like 2021 right now, and maybe it has, well, advanced, and it's for free. Mushroom is for free and has this node-based reconstruction system. Don't know, kind of user-friendly, but not in the beginning. Agisoft Metashape, it's the cheapest one. Autodesk Recap, if you're a student, you can apply for a student license for 3 years. And the downside of this all software is that you need a PC computer. And for Agisoft, Metashape, Mushroom, and Reality Capture, you need a CUDA cores on your graphics card, NVIDIA RTX or GTX, something like that, and it's then gonna work. Yeah. But Autodesk Recap, you only need a PC. You download it, and then you upload the images to their server. They put you in queue. You wait. Then they send the result. You edit it in their software, and then you export it. And I think that's one of the best choices if you're a student. If not, yeah, Mushroom. But I really suggest Reality Capture. Right now, it's been bought by Unreal Engine, by Epic Games. Epic Games has Unreal Engine, and Reality Capture gone much cheaper right now, and it has a really nice licensing system. You can download Reality Capture, you can reconstruct, but on the exit, you need to pay. You need to pay for the images, image amount. So, for example, 28 images, 18 megapixels, it was like €1.50, like €1.50, something like that. And it's really accessible. If you have this rare object one time, I think it's a really good option to pay. It just saves you time and nerves, and the quality is over the top. So yeah, and let's check out the software. So I'll just check if there are any questions. No questions, great. So we can move on. So, okay, then let's take a look at the software. Yeah, the first one, yeah, the Reality Capture. So it looks like this. Reminds me of like Microsoft Excel or Word or Windows Explorer, something like that. It's really similar. And yeah, I'm gonna just throw in some pictures. It's simple as that. We just go through. All right, where's my folder? Here we go. So I'm gonna use photos of me, of course. That's from the my when I took it in my cameras. Well, my studio. That studio was in a collaboration with Overlay. Those 28 cameras, and let's try to align them. Well, what time is? Oh, it says it needs 2 minutes, but I think it's gonna be faster. Yeah, the best part is if you have a compatible video card, and you can have a really, like, the computer must not can be also not so fast, and it does a really good job. And yeah, as you see here, we have this point cloud, a rough point cloud, and we have those cameras aligned. Okay, no light there for me. So, and it has those cameras aligned, those perfect positions. And the next thing that we need to do with it is just show the position, just show the where it should be. Yeah, what region to reconstruct, because if you're taking the whole room, it's going to take a lot of time, a lot of vertices, a lot of, well, it's not worth it, of course. Well, if you're doing spaces, yeah, then of course, if you're doing some rooms or parks and stuff like that, of course. But right now we only have one point of interest, and that's me. Let's then reconstruct. Right, we really don't need to do anything here. Yeah, if we have trouble, if our hand was shaky and we'll have too few photographs, and the images aren't connecting together, then yeah, you can use control points. You can show, if you see with your eye that, yeah, that's the same point in that image, and you have a lot of them, you can force to combine to combine the images. Because yeah, let's take a look at those images. So you see the green dot. I don't know if your quality allows that in your end, but the green dot shows that it's being used and it's being seen. So by clicking on one image, it shows a number, and it's the number of feature points available right now in what images, like for this image, the next image, like 75 feature points. So, okay, let's then take another step. Let's take a normal detail. It's maybe gonna take a little bit longer, but yeah, I think it's gonna finish right now. So maybe any questions? Okay, there were the comments. Yes, if you really good question. Yeah, if can we redo some things not to make? Yeah, you can do that. If you see that one part, maybe my, like here, I know that my like heads back what's the name in English, don't remember, is more rough because of less pictures. If I have the same lighting, the same everything, well, it's best for static objects. If I can still everything is the same left, yes, I can go take more photos, I can drag them inside, and I can again press reconstruct, and it's gonna attach those images. And also, when this finishes, it has this reality capture also has this helper tool, which can in real time, you can connect your camera to computer and upload the images straight into reality capture and see how it reconstructs and take photos at places where you need. It's very flexible, yeah. But the problem was that you cannot really remove. Oh no, you can remove in one setting, but there's this strange thing that I was previously using Agisoft Metashape, and I found it quite comfortable that you can delete some feature points that were placed wrongly. You can just select and delete them, and you can like fix some errors there, but right here you cannot do that. But I think like working for some time with reality capture, I think that's even for the best. Yeah. Well, yeah, you can make weird art with, with blurry pictures, of course, but remember, it works only if it only can find some logic and can reconstruct in 3D space. You can experiment a lot with it. Yeah, you can try and change, but most often the results are the same. It finds something, and the results are really, really well similar. So here I am. Okay. Here is Alvis in 3D. Have some detail from 28 old cameras. I think the result is really good. As you see, the pictures also, my head is really small in those 18 megapixels. You've done a really good job. The next thing I do, well, the model, the next thing I do, I reduce the vertices count, the polygon count, because when sometimes, well, it's needed. I know that I'm gonna put those in an A-frame later in webGL. So yeah, I need that model as light as possible, but I still need to preserve some details. And here I'm using the simplify tool. Let's go to the record. Yeah, here it is, simplify tool, and we'll change it to 500,000. 500,000. Here we go. And let's simplify. Because yeah, later when we import the head in Blender, Blender has some hard time on loading a lot of vertices. So it's best that we a little bit like make it easier for it. So right here we have our simplified Alvis, and the next part is let's project texture on top of it. And yeah, while it works with this, let's take a look at well, I won't show you the Autodesk recap. Well, it's really simple to use, and well, this one also is really intuitive, but there are some things that need to be done because of this specific workflow. And yeah, where is it? All right, the downloads. Let's open up Mesh-Room. I think our computer can handle it. All right. Yeah, this software is called Reality Capture. The company name is Capturing Reality. And yeah, see, like zoom into my skin, you can see the pores. You can see all the imperfectness of my skin. See, we have some bumps and maybe holes and stuff like that. But yeah, we can fix it in post. So yeah, the last step is export model, and we usually choose the OBJ because it preserves the 3D model separately, It gets the model, 3D model separately, and the texture also separately. Yeah, and we can work with that afterwards. So I already have like exported it. I think I have here the version where I need to paste, so I won't export it. It just throws another dialog box, and you just need to press export, and that's it. So yeah, let's take a look at Mushroom. It's gonna. Okay, well, it's opening up. Yeah, here is an example of how, if you want to rotate only the object, how it should look like. Just a second. Ah, yeah, here it is. See, here's a statue, wooden statue of Buddha. It has like tons of features. It has a little glow also on it, but well, yeah, it somehow autocorrects. It's not a big deal. You see, do you see the background where it is? No, we don't see it, right? So, and that's the point. Yeah, I need to just like erase the background. Yeah, if you cannot set up the studio for that, then another way you can cut out the 100 pictures. Right, let's take a look. So, and here is Mushroom. Well, and it works really similarly. But the best part here is that you can how do you say it? Yeah, edit the workflow and have multiple outputs. Yeah, okay, let's, for a comparison, let us check that out in the background. Okay, here we go. And let's take a look at the process. So I see it's, yeah, okay, camera initialization. Yeah, you can see like a dissected version of what's the process underneath. And the feature extraction, so the image matching, it has the features, so it's matching the images. Then it's matching again the features, then it uses the structure from motion, as I mentioned previously. Then it just goes straight to, yeah, prepare dense mesh. Then it creates depth map from the images and the feature points. Depth map, yeah, it's quite cool feature because, yeah, you can achieve like some micro details also if the pictures are great. And it does the mesh, and it does the mesh filtering. And the best thing here is we can skip some part. We can tweak any part. We can, well, here's the place. Yeah, we can also like, it's more possible for us to make art here than there. Let's just start it and hope that it won't roast the computer. And see the line up here, it shows the progress. Here again, you can see what's it doing right now. Let's check the computer resources. What does it do? Like the performance. Yeah, it uses the CPU 100%, the memory, GPU 100%. Yeah, that's, well, a hot situation. So let's close the reality capture. Let it work in the background. So let's then, I think, let's take a look at our model, how it looks in Blender then. Okay, so another question. Yeah, a really good question. Like cats, yeah, you must get like only get a stuffed cat or get like 100 cameras around and just throw a cat in the middle and just take a snapshot. And yeah, the hair is big trouble. That's a really good point. Well, I was the perfect model for this studio because, well, I don't have any hair that got my head distorted or something like that. Because I had this like distinguishable features and the head went out perfectly. Like people with hair, yeah, usually you put some kind of a sock on top of it or some kind of cloth you wrap around your hair, because, well, hair, what is like small strands, it's shiny, and it's not anything that you want to scan. Yeah, yeah, very simple advice. Yeah, like capturing like bushes in the leaves, um, like bushes in the wind is also not a good idea. But there's some interesting, like you can have like interesting texture and results if it achieves on reconstructing. No, noise base. You mean like only like with noise? There would be. It's really tricky for it. That's a really good idea uh, to feed in noise. I kind of had not the well. I kind of imagine that it maybe won't work because the features are so abstract and so similar in many places. But I think that also would be really, yeah. I think that the thing that's the thing, that random nature of noise will not, well, yeah, that's, it won't make any like conclusions. It's maybe if you like what was the name of that test when you throw some things up in the sky, like four things, maybe like 5,000 times or 100 times, maybe will form a square or something like that, but the other time not. And we feed a lot of noise, maybe it will find in some specimens, maybe some kind of reconstruction possibility, but not really. Well, there's quite interesting like photographing rooms with mirrors. It like makes this interesting, like another room on the, like as the room on the other side. And that's the thing you can like experiment with, like making some objects, making one side or some sides reflective, and it tries to reconstruct that reflection also, and then it goes into the mesh, and you can have some interesting results there. And all right, let's hide it away. Yeah, mesh room is really, it's not so efficient as reality capture. But let's open up Blender, and I think we are ready to step on to the next phase, which is like oh yeah, retopology and texture baking using Blender. And that is another really, well, here it gets even more technical. And again, if you go through it, I think it gives a lot of ideas for for artistic works to be created. So yeah, the Blender. So yeah, I have 2.91. There's a 2.92 version around, and here Blender is really nice. It prepared us a camera, a cube, and the light. And here, this part it really gets frustrated for some who don't do 3D stuff every day. Like I'm doing that from this what time was it, like 2004, I think, something like that. And I used Autodesk Maya before, and then this magical software Blender came out and evolved. And I think right now, the Blender is for the general use cases, well, the best software, because, well, mainly because it's free and it weighs only how much, 180 megabytes, and it has this like rich suite of tools which you can smartly combine together and achieve really great results. So about how Blender works, well, I think it's not this course. I think it's more today about the workflow. So you see how the workflow goes. And let's press the A hotkey. Let's delete. We don't need anything here. I'm gonna go and prepare my object. Now here it is. By the way, we can. The interesting texture from reality capture, as you see here, it gives us an OBJ. Well, here's the folder. It gives us the OBJ model, which you can view. If you have a Windows, you can, I think, open up and it loads in and shows you the model. If you see it, good. If not, it's okay. You can import it in Blender. It gives this MTL, which is like texture information. Most of the time you can delete it. It only shows that this OBJ is connected to this image, and you can change it in, like, open the text editor and change it afterwards. But the interesting texture that we get out of reality capture, you see here, some parts like mixed together and thrown around. And this is another hard point in like 3D, that you have this 2D image and you have this 3D object, and how do you project that 2D image on the 3D object? Well, it's basically really simple. It's just like origami or something like that, when you just wrap an image around or wrap a present. Basically, it's that. And here also, the reconstructed model is projected depending on it tries to make the texture so it doesn't deform. It has some kind of algorithm, so it just takes some parts and scatters it around as effectively as it sees. And it's best if when we are going to the retopology and texture baking part, it's always best if we can correct the UV map, make our own, so it's more like logical. Because here, if we also want, like, we can like open this in we can open this image in Photoshop and put the tattoo or some kind of drawing on top of my ear or cheek or anywhere else. But it's quite hard here because maybe in some parts it dismantles. And it's good if we can redraw that. And the UV mapping is, well, for some who ate enough UVs in their life, they think that, okay, it's just it's a process. It's okay, it's normal. It's interesting sometimes. I need to figure out, it's a little puzzle. How can you effectively combine and place the UV layouts? But for the beginners, it's really frustrating. And it's like a problem. The UV mapping and topology, it's a problem in the game industry and the, well, CGI industry for 30 years. And there are some tools that do retopology automatically, and they're good. Yeah, they're mostly good, but they can be not as effective as needed. So I think I'm here. Yeah, let's import myself. Let's just take a look what's happening there. Well, yeah, it's gonna take a lot of time, so I'm just going to stop that, close it off. It's still quite long. Yeah, you saw the difference. Okay, here I am. So yeah, first let's arrange ourselves. Let's press R for rotate. X axis 90 degrees, minus degrees. Yeah, Blender is really good with it has these really intuitive hotkeys everywhere. You just can, you see, I don't even use the tools. Just if I want to rotate, I press R, the R button, and all right. I think, yeah, this part is like a culmination, like where your frustration and anger and everything, like if you're doing the first time, like combined, right? Like, well, like creating art. the feelings are really similar, and in the end, yeah, when it's ready, just like when you're putting it into webGL, into like A-frame, it's really like a roller coaster down, really fun and easy. But yeah, we need to prepare it, because right now, let's check it out. It has, well, we know, like we can see the scene statistics. It's like 249 vertices. Yeah, well, that's, well, maybe you can show it on some, but some phones will be slow on this, and we only could have one head only. But if you want to build a rich scene, then it should be more. Yeah, we will need to optimize, need to figure out how to make it lighter, but not lose the detail. So again, then let's take a look about the texture bake part. So yeah, before that, yeah, the UV, what I was bragging about for some time. Yeah, and basically, yeah, it just how to make UV flat to 3D. And yeah, the baking in the game industry, like you can mostly, if you know the game engines, the thing is that you cannot do real-time shadows all the time, because, well, it's really resource intensive. And if you have some like palm trees that are static, or some objects that are static, you just bake the shadow onto the texture, and that's it, and nobody notices it. And for the active objects, you just only put the dynamic shadow. And here we bake, yeah, here we do with photogrammetry, we do more like reproject, more like reprojecting. And we have this like our high poly model. We then turn it to, we duplicate it, we reduce the poly count, or retopo, do a retopology on it, and then we bake the old UV to the new UV. And the thing that we're gonna bake is a color and a normal map. What's a normal map? No, it's not in like normal Joe or something like that. It's normals are like in the 3D world, it's the direction of the face, the direction of the polygon. And I'll show you, yeah, the normal, yeah, as you see here, like a 3D object, and it has this perpendicular against the object. And what's our normal maps? We have our complex model, and if we want to preserve all the details, or all the creases and all the small fine small defects, then we can do this kind of a trick, make it a low poly, really smooth, and we can reproject that rough, that surface, the format, well, the surface irregularities. We can project like a texture map, and that texture map simulates how light falls on it, and it looks like something like the map looks like this. As you see, it's simple. You can like create it in your studio if you have a green, red, green, red, and blue light. And as you see, like the green light is coming from up, the red from the left to the right side, the opposite, and the blue from the left to the upside. And that's how it determines what side, how to light the model. And here's an example. As you see here, on the right side is a low poly model. It has only like 6,000. In the middle, it's 6 million polygons, and on the right side, it still has like 6,000, but it looks like a 6 million, right? It's how to make furniture that looks like a million. There are some errors right now I see on that model, but still, you see, you can get that high level detail without suffering, without making your equipment boil. All right, then here's some links and bake tutorials, also some in detail. Let's check out how does it look like actually in Blender. So yeah, the first thing we need to do is, like, we have it here. Let's zero out everything. Look here, I'm like 43 meters, but well, I'm not so tall, even the upper part. So yeah, let's just make a meter. It'll be easier afterwards to, I won't measure myself right now. And yeah, we'll just rename it like a high. Let's duplicate the object and make the low. Well, usually there's some tools that, well, if you want to animate it afterwards, and if you want to make it for like in the game engine, so it's does something that you need to do retopology. Well, and what's retopology? It's the way the geometry is drawn, how it's constructed, and yeah, let's put on a decimate modifier on top of it. So let's make decimate it. It is like a surface aware, and it does a really good job on estimating where to make the mesh geometry denser and where not. So here we go. We have right now like 24 vertices. I think we can try to lower it even more. Let's take a look. As you see, the rough geometry edges are beginning to appear. Oh, yep. And here we have this low poly art style right now, right? But it's gonna be a little bit too low. Let's go to the 8, one of the 8 part. All right, let's just shade smooth, so make it visually. Yeah, I have some errors some places, but we'll fix it. I like the count, like 20,000. You know what? Let's make it even lesser. Yeah, maybe. Let's try and let's apply the modifier so it doesn't recalculate every time we do a change. And yeah, let's then, where do we have this kind of rough edges? Yeah, the sculpting tool is really interesting, really great here in Blender. Also, we can like smooth out parts. Oh, need to put out the strength a little bit. Let's do like smooth out. Yeah, I'm like ruining the model a little bit. We really need to be careful here what we are doing. So let's correct the ears, but we don't have, yeah, we need to dyno topo turned on, but I won't do that now. That will take some time. Need some modeling. The modeling, yeah, part is take an hour. But yeah, we fix those things where we see some kind of strange irregularities, because it's gonna be a really frustrating thing afterwards. So yeah, I think it's gonna be fine. Ah, here is another one. Let's go back to layout, and I'm just gonna cut off some things with, like, yeah, what will be like this modifier boolean difference. Yeah, let's select this one, and it's cut off. We have a straight. I would cut off probably a little bit lower next time, but it's gonna be fine. So here you have our two models, one low, one high. And the next thing is, yeah, the UV map. That's as I mentioned, the industry is still struggling with it. There's no fine tool to work with it to make it automatically. ZBrush has some good, some really good, well, easy, intuitive tools to unwrap in UV. But yeah, it's still, in this case, it won't do. So yeah, right now we're just going to the UV editor. Let's take a look. How does the UV look? Yeah, here it is, and it's all around. I deleted stuff. It's a mess. It's just an ugly mess. What we can do is, let's select some edges, and I'm gonna, well, it's like, yeah, cutting something. Yeah, taking the skin off and then putting it back on. Simple as that. Here I'll turn on the mark seam, and of course mark seam the bottom. Somewhere probably also need to cut in here. Yeah, the seams is like, well, when you're making clothes, the same. You try to put them in places where some things collide, or is it less seen, somewhere hidden. Because if you put some kind of random texture on top of it, it's quite, yeah, you have this like straight cut lines. See, like mark seam. All right, I think, yeah, let's cut another one here. Cut my throat here, and let's see. Let's take a look how it's gonna be like right now. Let's unwrap. Yep, here we are. Let's remove this image. Yeah, here we are. So here by priorities, you see, I'm not using the whole image quite effectively. And the thing I'm gonna do is, let's go here. I'm gonna choose the islands. Well, this part isn't so important for me. I'm gonna make it a little smaller. This part is gonna be really small because it's, well, I don't have any anatomy here or there. And let's, yeah, try to somehow make it bigger, because, well, every pixel counts. I think we can do a better job if we cut even here. Mark seam. Let's unwrap. Let's unwrap only this one. Unwrap. It unwrapped again all. Well, that's okay. Let's just make it smaller and tape in pack islands. Well, it's better, but yeah, Blender has this. It's really not so good. The thing here, yeah, let's make it a little bit bigger. Yeah, I think it's gonna be fine. No, not need to keep the proportion similar. Let's, Yeah, I think this part is smaller. Is it? I just needed to rotate it, but no, it is smaller. All right, good. So here's, you can put on the floor. You probably can understand what to expect from this. Let's go and bake it then. And there are a lot of different baking methods. Firstly, we need to check if the texture is there. Yep, it's here. Let's make it shade smooth. And we can use the internal Blender baker, but we also can use a plugin. Find on the net. I found a really nice one in GitHub. It's called Easy Bake, and it's a really nice plugin. So because, well, as you see here we put the low poly, here we put the high poly, here we choose the distance where the reprojection where it searches, and texture size. Yeah, this is important thing. Our end goal is the webGL. So and there's a problem with images. Like, you cannot put a 4K, 8K or higher. Yeah, okay, yes, you can. But it then resizes it dependent on the device you have. If you have an older device, then 4K won't do, or won't work. So it will need to automatically reduce the size, and it's going to take time, and it's not effective. I think so. Someone can correct me if now otherwise. And let's, yeah, the padding, it's how much it bleeds. And let's choose the right. Let's choose our correct folder. Right, except let's put in the name. Well, and the texture bake part, it's really fun. Yeah, you can also make a lot of artistic, funny things, and that I'll show you in a moment. I'll do one correct one, and then I'll do the one funny. So export, okay, alv mod, something like that. And the thing we need to click here is tangent normals and color. Okay, let's press bake, and it's gonna work for some time. I think, well, it usually isn't so long. Let's take a look, maybe. Oh, yep, here is our normal map. As you see here, oh, nice, like a picture of a moon or something like that. Here's my face. And here you see where there's these green parts, that means some kind of errors there. Oh yeah, and here we have like a butterfly face. Really nice. And yeah, we can see some artifacts here. And what we need to do is, I imagine, let's rise the number. And a little bit, like, yeah, I understand what's the correct size of it. And okay, let's take a look. It overwrites. Oh yeah, you see it's better. There's no artifacts there. Well, there's still a hole in the head, but we can fix it in post. I don't want to make that number much higher, because there, again, it's going to be some different defects. Okay, let's hide this one. Let's project everything on a cube. What do you think? Let's try that. All right, let's try. Grab Z. Let's check the UV. Yeah, the UV map is like this. Well, we won't change it. It can be more effective, but let it be. And right now, let's choose the cube. And it's important to change the name to 2. Let's bake. Ooh, material on a low poly mesh. All right, thank you for reminding us. The text was here under a little bit. Yeah, we need a material on top of our model. So let's bake again. All right, let's open up the. Okay, let's open up beforehand the cube face. Oh yeah, here you go. Yeah, you see, it's like taking photographs from different sides. It's like photogrammetry, but reversed a little bit. Yeah, my nose is outside. Let's try and enlarge this number. Let it be 1 meter. I'm 1 meter. Yeah, this is 1 meter. So, well, the ray is gonna go really far. Let's bake again. Take a look. Probably will be the model will be ready for Minecraft. Is it better? Don't know really. Yeah, the nose is inside, but yeah, it's much better, but not enough. Let's try and make it smaller. All transforms, and let's bake now. Oh yeah, I need to make it really inside, and it's gonna make, yeah, it's gonna be more funny. It's gonna I'll project everything like on top of Qt except the head right now. Yep, it's a little bit better. Right. Scale, grab Z, Command A. Let's, oh, this is gonna be the last one. We'll move on to the next part. Yeah, the next part, the most fun part. All right, so yeah, I'm only a little bit closer. So how does it look like? So let's hide the high poly. Oh, nice. Nice. It's the old texture on top of it. We need to remove it, but yeah, it was really, really nice. So, but let's change it to our new one. Command V. Where was it? Yeah, this one was it. And let's go to the shader editor. Okay, here we have our Command C, Command V. Here we need to choose our normal map. And let's, yeah, we need another node for that, like normal map, like an interpreter or something like that in the middle, in the beginning. And let us add, see here, we need to use non-color. And let's put some light. Let's put some light on it. Command R, and let's go to the render mode. And you see we have our low poly. It shows a little bit like the effects are glitchy. We have some high details preserved, but well, it's really lightweight, as you see, as was the goal. And right now, let me hide it for a bit. Let us take a look how this cube looks when an object is put on top of it. So let's Command V, and again, image text, no, normal map. Normal color. Oh yeah, nice already, as you see it. All right, see, like linear non-color. Yeah, that's gonna be better. Yeah, as you see here, and I can rotate it, and it simulates, and it simulates really nicely the depth. It's like Let me like rotate the light more. Rotate. It's like a cube, but you see it's not in the same time, and gives this like magical. It's like really nice low poly part. Even I think the texture is even. We can use it as a moon. The texture is even, I think, not necessary right now. But if you want, yeah, we can have it to like rotate. Yeah, you see how it transforms the light? It's cube and it's not a cube in the same time. Oh, all right. I think I really like this part. So let's maybe adjust it a little bit. Here we go, a scared cube. And let's put a shade smooth. Oh, nice organic statues, low poly. Well, that's gonna show in some dreams, no? That's okay, hide it. Let's open up our, oh, you know what? Let's not deform it so much. I think it was better way like when it was a cube. And yeah, what can we do next is work with textures. Well, no, work with the shader. And what about the shader? So the shader makes, well, we can make all kinds of effects on top of it. For example, we can go and you see we have these all channels like metallic, specular, roughness. We can add some black and white maps there, so we can show where's what's like the shininess level of different parts, the color of different parts, and stuff like that. And yeah, it's done. It's done here. We go to texture paint. We need to find our object now. And yeah, let's choose a color. Let's choose a layer. Yeah, here's a normal map. Here's our simple map. And what happens? Yeah, we like just put some kind of blue line on top of it. Like, okay, see if we can draw it on top of it. Great. And let's add another, like a roughness map. Yeah, and the bad thing here is that we don't see it. Now there was, oh, I forgot, how can we like make it visible? I think we can make it visible. We can make it visible on the, yeah, let's go to the shader editor again. Here's our map. Okay, let's just draw. You see here, something like that. And let's take a look how our model looks now. So let's get back to layout and generates. And you see here where I draw these lines previously, it's more like the wetness is there more. Yeah, let's drive the specular a little bit more. You see the material here. The eyes are wet, the nose is a little bit, and here it's a good spot here. You see like from something from the ear coming out. All right, I think let's rotate. Let's finish this up. Yeah, the possibilities you see here, it's it gives some emotion a little bit on top of it. So Yeah, I think we have this model ready, and it's 8 o'clock already, and we have like our last part for us, which is the webGL part. So that's the most the best thing. So we want all this this long road for making our objects visible in web VR, our own objects. And yeah, let's go to switch back to the presentation, wherever it is. Here it is. So yeah, and webGL. Well, webGL. Well, for some who understand it, the name it's probably would be scary and really low-level programming. But webGL is a web graphics library, and is a web technology that brings hardware-accelerated 3D graphics to the browser without requiring the user to install additional software. Well, imagine it's possible right now to make a. You just type in a link in a web browser, and you can be in VR. Which is like for me, I think it's like magic, and you don't need to go through heavy coding. And so if you survive that long listening to this meetup, then workshop, then I think this is the best part, because well, you can always find any free or what models on the internet and use A-frame. And what is I always mention like webGL, A-frame, but what's the connection? So webGL is just a graphics library. It's a set of instructions to give to the video card and video the graphics processor, and on top of it, one of the popular ones. On top of it is some, you can make some say like JavaScript functions to use the webGL to send instructions to them. And one of the most popular sets are not the sets, but one of the popular frameworks is Free.js. Okay, the link doesn't work here in presentation. I'm going to type in, and there are a lot of really nice examples of how can you show like 3D content on just web browser without installing anything. And it's really accessible, and it's here, and it's yeah, I just need to a little bit. It depends on what kind of project do you need. Often if it's something complex, then yeah, a programmer is needed. But if something like simple showcasing sculpture or anything, it's really good. You see here, it's probably you have this really jagged experience probably here, but as you see, it's some kind seems rendered. Seems that it's like pre-processed, and but no, not really. It's I move it with my mouse a little bit, and I can interact with the wall that's behind. And it also put this nice collection of effects together that looks like it looks realistic. And yeah, the one thing what I wanted to show is this festival. I think it's one of the best showcases. One of the best showcases of like a box of assorted candies for WebVR, no, for WebGL, and the name is Aquarium. Maybe I understand it needed to happen last year here in like Liepaja also. Did it happen? Don't know really. Yeah, the best thing here is, yeah, you can scroll through these like different 3D worlds, and yeah, get inspiration from it. I won't show till the end because, well, I think it's the experience for you on that end isn't the best. But Another thing what I want to show you, which I used for quite a time, is Sketchfab. Well, it's a platform where you can put your 3D objects inside. And there are some really good, well, it's perfect because, yeah, you can use it to like show it like in, it offers you to show it like in augmented or virtual reality, and it's easy and you can achieve really nice graphics there. Sometimes you can even subsurface different effects that looks realistic in like a 3D picture. Okay, it's loading some textures now. Okay, see, like shoes, for example. Also use photogrammetry. You can zoom in and see the detail of the shoe. Like it's, well, it depends on the places, but yeah, often you can, it's like a 3D photograph. And yeah, 3D and photograph doesn't go together, I think, so much here. Yeah, and it can often when we've done some works in Jan's Rosenthal school, we often publish it here, but now we are going to like do our own platform. We're establishing it slowly using, well, A-frame. And someone interested in play canvas. I still didn't try it, but it looks like, yeah, if you did something in Unity and Unreal Engine, something like that, it could be like the play canvas is like a game engine for a web browser, and that, I think that is really cool and awesome. And the thing that, yeah, well, like some words for webGL. Well, I think it's the graph. It's possible because well, right now some things look like maybe like from back like 10 years. The graphics are, well, not so high end. Well, but they work on all devices, and I think it's really a best time now to jump in and make something in WebVR, web AR, and get like to know the community and evolve with the industry together. Because like jumping in like 3D rendering or movies or production, well, it's really hard. They're really gone far, and the learning curve is really steep, and the contest also is really like abnormal, yeah, well, really hard. But this thing, like if you can do, and if you do something on WebVR, on a web platform, like making some kind of interactive 3D things, that's a really nice niche, and there's a demand for that, and there's going to be a big demand, and obviously in the near future. Like right now we have some projects, and also it's hard to find someone who can program some things for web. And also, well, the hardest part is find someone who understands the shader and how can make the visually aesthetically pleasing and artistically interesting. No one who, yeah, not a lot of people who gives that. Yeah, jump in. It's the best time. Maybe for the NFT market, it's a little bit too late, maybe something, but in this, it's you can jump in here. A little bit harder to earn money, but you can. Yeah, so the A-frame, what's an A-frame? It's just a web framework, well, building 3D AR, VR experiences. Well, as I mentioned previously, like there's this webGL, web graphics library that's connected to the hardware, and then the next layer comes that Free.js. There's also Babylon and some other you can find, of course, but yeah, Free.js is more popular. The next layer, and another layer on top on WebGL and Free.js is A-frame, and A-frame uses only HTML to put objects in place. It's like a basic game engine, something like that, and you don't need to do logic, do code, do stuff like that. It's all like semi-prepared, and if you want to access it, you can. And yeah, well, HTML, as you know, probably some of you worked in it. Yeah, it's not a programming language. It's a markup language. for documents designed to be displayed in the web browser. Well, it's like, yeah, upper stage from the backside. Just show where it should be and when. And yeah, right here in A-frame, we'll take a look at like 2 parts. Really simple. We won't delve into CSS or script making and stuff like that. You only need to understand that there are like 2 parts that we're gonna work with. It's the head and the body. I think it's, yeah, basically that's it. And the head usually starts with this brackets and ends with bracket, this line and bracket, and the body again, yeah, starts and ends the same, and all that encompassing is the HTML. As you can see on the right side is the HTML. Here it begins and it ends in the end, of course, and in the middle there is head and there is body. In the head you place scripts that's going to be used in the body. You take a bicycle, you take some kind of tent, stuff like that, and then in the body, that's the execution part where you use it. And yeah, for example, yeah, in the header, you see that you have this again script, which also has its brackets. You put the link for the script, and you end the script, and you end the head. You can put a lot of scripts, but there's only 1 head and 1 body. You don't need more, right? Well, yeah, and little mistakes like in programming also here in HTML can cause the code not to function. And the first 90 steps of time is spent on searching for punctuation errors. That's true, yeah. And it's best, I recommend to use comments to organize your lines. And you can comment things with, as you see, this press it, what's underneath, and you can type in any symbols, anything you want. It won't be read. And here's an A-frame example in HTML. So you have the head, you have the script, A-frame script, and then you have the body, and you use the A scene, which is from the A-frame script, and in that also you have the A box, which also is from that script, and you access the attributes. Default is 0, 0 for everything, but if you put outside here the position and the rotation, you can change it, and it ends here, and that's it. You have it here. A-frame, if you don't put the camera or lights there, it puts its default lights and cameras, and yeah, it's all settled. And when you open the experience, you can also use a VR button, and it also throws you into VR glass. You can walk around your object. That's really fantastic. Well, yeah, the hard part is, doing stuff with HTML and the web. You need a server, you need a domain name, and stuff like that. And it's best if you can find some kind of umbrella, someone who knows and can set that up if in production. But for playing around and to getting better to understand how the code works and how the world works, and for even simple home pages and projects, you can use glitch.com. So let's go to the glitch. And yeah, it's really really good and fantastic platform. You can share, you can work multiple people on one project, you can like write code like in the same time and see what other is doing. It's fantastic, and in the end you can just send a link to anyone and just work. So okay, let's prepare. Let's press a new one, and let's see how the glitch works. So we can also here's our page, what the viewer sees, and here's our index file, what we need to write, so only this text is seen. But we won't do any text like this. We will only use A-frame. So for example, see, I can put more, and yeah, it updates simultaneously almost. And when you press on the big one, you see you can copy this address to anyone, and it will see your content there. One thing is the platform is free, but it has like 500 megabytes limitation. I think that's really enough. Problem, of course, if you have a lot of projects there, but that's not a big problem usually, because, well, developing things in WebVR, the main goal is to make it as light as possible, so you can load simultaneously, even if you have mediocre and slow internet. Yeah, let's rename our project. So let's Alvis cube, cube. Here you go. Yeah, and what happens? See, the address also, the name goes in the beginning, and all you need to deal with is glitch.mean. That's not so bad. It's nice name, glitch, no? All right, let's get on rolling. Yeah, that was the end of the presentation. Let's go to the A-frame IO. And here is the A-frame homepage. And the most important thing here is the documentation. It's really simple, it's really precise, and it has examples. And all that we need here, you see, copy that. And there's one minor detail. Yeah, let's change it to 1 because the newest version has glitches. And you see here we have, well, our 3D scene. Let's take a look. And we can use the arrow keys to walk around. We can use double the ASD to, again, walk around and do stuff. And yeah, that's it. And here it's all visible and understandable. Here's the box. All right, yeah. Well, let's type in 1. What's gonna happen? Yeah, it's a little bit higher. Let's make it more visible. Let's put in 2. Yeah, you see here it goes up. And simple as that. Even I think easier than working in Blender or any other game engine, because here you see you don't need to find, you only need to type. And yeah, where you need to find is here, and the documentation is really fine, great. So what we need, we want to place our object there, right? So let's delete everything except the sky and the plane, because we need some kind of orientation point to understand if our model loads or not. Let's go back to Blender, and oh, almost forgot. And one thing that we need to do with this is yeah, export it in correct format. We can export it in OBJ again and texture files separately. That gives us flexibility, but a little bit more complexity. But usually I suggest just use export it as export GLTF. That's it. Okay, HTML. Let's copy, resend, export, and cube alv. All right. It's important to select the objects only because it's gonna export everything that's in your scene. And here, just to JPEG. Let's turn to JPEGs because it's gonna be 3 times lighter. All right, here we have the assets. We are just going to find our, yeah, before GLTF viewer. Just throw it in here, check it if it works. If it works here, it's gonna work everywhere. Yeah, it works. All right, I think I have my new profile picture ready. All right, let's throw it up here, and let's copy. Really nice size, 470 kilobytes. Perfect. Like how much was in floppy? Can I store this in floppy? I forgot how. I think I can, no? All right, so yeah, the GLTF, let's find in documentation GLTF, and here it's shows how can we place GLTF object. So there are two options. One is using inline, using the assets that before opening the scene, it loads all the objects that are in the assets lines. If not, then I think simpler is better. Now we'll just copy it as just like when it loads, then it shows. It could be a problem for heavier objects. And path to, yeah, let's copy the path. Copy inside Command V. Let's take a look. Maybe. Is it too small? Oh, yep, it's 0 position. It's here. So yeah, we need to change the position a little bit. Position. Oh no, different. Oh no, why not? Position. 0, 0. No, let's put it 1 and -5, 4 maybe. Yeah, because it's in the center of the plane. We can check that out. And yeah, we need to change the scale to scale plus 222. It's like x, y, z axes. Let's put it like 5. Yeah, it's a little bit too small, but it's gonna be bigger. Here we go. All right. And the light is awful. It cannot understand what's happening here with the light. So we need to add our own light. Let's just type in here light. And yeah, let's put one directional. Command C. Command. We need to do this all in the scene. Do it outside, it won't render. Here's one light. But here it gets a little bit frustrating. How to control the light? Well, let's go to our 3D view and press Ctrl-Alt-I, like inspector. And here we see the light. And here we can adjust the light. Oh yeah, floppy is 1.4 megabytes. Yeah, I can almost put two of my cubes there. Oh yeah, good question. The scaling, no, it doesn't. No, it's you mean for the image texture? Well, the image texture as it is, it's like it is. But for the geometry, no, it doesn't. It has, well, yeah, if you put the big object and pour texture, then the edge is always going to be sharp as you want to like enlarge, but the texture on top, yeah, you could see some defects. The texture, it cannot get, it is what it is, like, yeah. If you know that it's gonna be a large size, then you need to like divide it in parts, something like that. The biggest problem is with the texture right here. But if you have only like solid geometry, that's gonna do just fine. Oh yeah, here is a little bit like creepy line, a little bit like, oh yes. Here, and what we want to do is just copy the entity. Let's go back here. So the upper copy, and the light's gonna be in the same position. Let's go around. Yep, here we go. Oh, it looks like I'm crying. Funny. And yeah, you can put like, I don't recommend putting a lot of lights there. I recommend maybe 4 or 5. 4 or 5 lights. So yeah, if more lights, then it's gonna be only like really heavy for the mobile devices and for VR. Command C. Let's copy in an ambient light also. Let's make it more tidy. That's too much. Ambient, let's copy the intensity a little bit lower. Intensity 0.5. Oh yeah, yep, that's better, I think, yeah. there's no darkness anymore. The ambient lights. You have this like kind of don't know understand like is it 3D or is it 2D or so what's it like, and yeah, that's the magic of understanding the 3D. Yeah, okay, let's try to scale it up. Well, for example, let's scale it up only on the y-axis, like for 20. Well, of course, yeah, the texture is, well, it can be recalculated, like to make the texture. The problem is, yeah, well, Photoshop had a new feature like enhancing the rescaling the texture, but yeah, it doesn't work like that. It doesn't interpolate. It just makes it softer. Oh, here we are inside the cube. Something like that. All right. So, are there any questions? I think that's like it. Like from scanning to make it weird. I know, yeah, probably it's been a lot, like a long journey. But if you're interested, like in doing this yourself, I think this video will be available, like a nice encompassing tutorial how can we make our photogrammetry objects visible. Yeah, and the photogrammetry part, yeah, it's more about you just need to try and do it again and again, because it's really hard to do it in the first time. It's you just need to feel the camera, need to feel the understand the light, and that's not usually successful for the first time. Oh, yes. I've been, for static objects. Yeah, the best thing is, as I showed you, the Buddha image before. Yeah, it was on that orange monkey named, or what was the name of the platform rotating? It was like emitting light, which was perfect. And I only put light on the background. I've put light on the background, lighted up, and made it all white. And yeah, I can even, if I have like 3 cameras, I can stack it on top of each other and trigger it at the same time, so I don't need to change height afterwards. We did this in scanning in the Art Academy, the sculptures. Some sculptures we put it on a rotating platform, and there was like 7 cameras on top of each other, and we just rotated one time, and we had like 800 pictures, and we could achieve like a really detailed, really heavy object. Couldn't fit on a floppy disk.
I have a question. So if you use a phone app that allows you to make the objects, can you still embed them in the A-frame?
Oh yes, of course. Yeah, you have. If you find this. The software, the apps on the phones, they're like changing all the time, and one's disappearing, one's appearing. If you can find a nice one that generates some results that you want, usually it offers that you can export a GLB file or an FBX or an OBJ, and yeah, you can like send it to your computer, and even I think you can even do all this prototyping and making your object on the phone also. You can open Glitch on your phone and you can do it all in one spot. Like that's not a big problem. Yeah, you can skip all that long process of learning 3D modeling and learning 3D scanning software. But of course, as we understand, there are huge advantages on getting to know those platforms also. Because as times as I try to use those apps on the phones, they're usually like, okay, I've got the model, then so what? It's ugly as everyone's else. So it's just like they're all similar. And how can we like jump out of that is, yeah, trying like a little bit diving deeper into the photogrammetry softwares and what can we do with the model afterwards. And there was, yeah, but really good, I think, useful results I have achieved with the iPhone 12. It has this Face ID camera. It's from the iPhone 10, I think, version. It's really, it's really high resolution scanner. And usually I can, once I scan like a baby, there like so some parts like one front side, left side. Well, it was moving all the time, but I tried to catch the same pose, and it got the best part with that iPhone Face ID scanner was that it had this proportions were identical, and it didn't need to do in Blender any scaling. I just assembled together, and then I made a 3D print out of it, and that was really like a good, like, wow. And it wasn't meant like that, but you can use the phone like that. It's fantastic. And the backside leader also, that went 12. I feel I kind of making commercial here, but I just fell in. There was the Samsung 10, and it had also this some kind of 3D depth camera, but it was just a gimmick. And I'm surprised that iPhone, no, it's not a gimmick. Like, you can do some things with it.
Thank you. So we have reached our end. I don't see any other questions now. So I think we can say thank you.
Thank you. There's one question more. In what way I have combined this technique with 3D printing? What way? I've just scanned, like, imported in 3D, and then I'm just sculpting and no, different combination of tools, and then just printing. Yeah. Well, it's a process, but yeah, if that was for artistic functional. It looked a little bit like, you know, like stylized, but it was also accurate, and that was really cool. Yeah, that I need. Yeah, I think the result was really good. Can show you now. It's a private project. Okay, so yeah, if no other questions, then thank you. Thank you for hope at least maybe you understood that what you want to do or what you don't want to do.
Thank you. Well, honestly, the Blender part was a bit heavy, but that
as
is
always. It's for everyone always. I taught to my wife also the Blender part, and she was like, why? Yeah, the third dimension, it's hard.
Yes, but I hope that when rewatching the video, I can get a tiny bit more into it.
Well, the more of the process, yeah, but there are a lot of nice Blender tutorials out there separately.
Yes. So thank you for the lecture. I enjoyed it a lot, and then we can stop for today and resume our hybrid lab in 2 weeks with a discussion. So thank you very much. I will now end the meeting. So
Bye bye.
Stay in chat. But this is it. Thank you.